So, welcome to this day of notes. Some of y'all might be like, area of triangles, what is that? We already know how to do that. We already remember that the area of a triangle is 1/2 the base times the height. True, but that's only if you're given the base and the height. And the characteristic of a base and a height is that they're perpendicular to each other. Not a lot of the triangles that we've talked about in this unit are right triangles. So we need to have new formulas. So if you're given a triangle that's side angle side, that's the angle that's between them, it's 1/2 the product of the two side lengths times sine of the angle that's between them. Now in this class, we give you these formulas, so the worst thing you can do is switch out sine with cosine. So be very careful. So here's a triangle where you have angle A, side length B, and side length C. If you want to, you can draw out the triangle and notice that the angle is between the two side lengths. So the area of this is literally just the side length B times the side length C times sine of the angle A. So notice that they're all different letters. So that's the only way that it's going to be that. And something that I forgot to write here is that it's 1/2 times all of that. So if you do that into the calculator, so 1/2, I'm just going to type in as 0.5 times 15 times 10 times sine of 115, you end up getting that the area is 67.973. There's no unit, so I'm just going to leave it like that. However, what if they don't give you an angle? What if they give you all three side lengths? Well, you do have the tools on figuring out that an angle. And again, if you're going to use law of cosines for this, you have to find the largest angle first. Or we have this thing called Heron's formula, where we take half of the perimeter and call it S. So half of the perimeter is adding up all the side lengths, so 14, and dividing by 2. And if you do that, you end up getting 20.5. So just make sure that when you're putting this into the calculator, 8 plus 19 plus 14, you do that first, then divide by 2. If you're not getting 20.5, it's probably because you're putting the calculator wrong. So Heron's formula ends up giving us a brand new formula where we're going to take, I'm going to leave that square root off till after I'm done. We take the side length S that we got and multiply it by the difference of that S with all three side lengths. So the 8, the 19, and the 14. And we're going to put that all inside the square root. So like a lot of the formulas in this class, just take it as it is. You don't have to understand where it comes from. If you want to, you can Google that. And for the sake of notes and time, I'm just going to type that exactly into the calculator. I wish somebody was here to tell me that I made any mistakes while typing this in, so I'm going to try to be very careful with typing this in and end up getting 49.984. So make sure that you're showing your work. So that's the new area of triangle formulas that we have when we're dealing with side angle side and side side side. If we gave you any other scenario, you have tools now to figure out missing information and use these formulas to figure that out. So a question that we love to ask in this class is for you to find the altitude from a certain vertex to a certain side length. So what I'm going to do here is I'm going to draw a triangle. I'm going to call this A, I'm going to call this B, I'm going to call this C. They're asking us to find the altitude from A to B. So let's see if I can get that to be as close straight up and down as I can, eyeballing it. So that's what I'm looking for. This is also called the height of that triangle. But they gave us all three side lengths. They told us A was 20, so that's 20 here. They told us B is 9, and they told us side length C is 13. So there's a lot of different ways that you can do this, but there's a right way and a wrong way of doing it. If you're trying to use like the side angle side formula, you need the angle that's between two of the side lengths, and you need to find angle A first because that's the largest angle. So If you're going to do that, you could do that. But in this scenario, I have all three side lengths. And if I have all three side lengths, I can use Heron's because the idea of these notes is we're using area of triangles. So to find find the area of this triangle using Heron's, I need to find half of the perimeter. So add up the three side lengths, divided by 2, and we end up getting 21. So the area of this triangle ends up being, the 21 times 21 minus 20 times 21 minus 9, and then 21 minus 13, all inside the square root. So the area of this triangle ends up being, well, I'm going to clear out what I did earlier. So square root of 21 times 21 minus 20, and then this one, and then this last one. I end up finding out this is 44.8998. So the 8 rounds a 9 up, the 9 rounds a 9 up, the 9 rounds a 8 up, so 900. Well, wait a minute. What does that do anything? Like, I'm asked for the height of this triangle. I'm looking for this. How does that area help me? Well, heights are perpendicular to the base. If I have a base and a height of a triangle, I could use that formula of 1/2 the base times the height, which I don't know the height, but I do know the base length because of what they gave us. Our base length is going to be 20. No matter what formula you use for the area of a triangle, you should get the same area each time. So if you solve this for h, half of 20 is 10. If you divide both sides by 10, you end up getting that the height is 4.490. That is the most straightforward way of figuring out the height of this triangle. It does change depending on which one we're giving you. So make sure that you're paying attention to what the directions are telling you. Because if it went from C to AB, the base length would be 13. If they said it was B to AC, 9 would be your base length. So pay attention to directions, draw things out. All right, then this next question. It's going to take us a little bit of work, but honestly, it shouldn't be too difficult if you understand what's kind of going on here. So they gave us some information. They gave us that this is a quadrilateral. So I kind of drew it out for you. Quadrilaterals, the only thing you know about it is that it's four-sided. There is no other piece of information besides maybe that all the angles inside add up to 360. But they told us the side length of AB is 37, B to C was 56, C to D was 44, and then 31. Then they also told us that the angle A is 52 degrees. And that's it. This is not a parallelogram, so C is not also 52 degrees. So what you're going to end up needing to do is figuring out a diagonal length. Now, the diagonal length that I'm going to look for is this one from B to D, and I'm going to call that X. Why that diagonal length? Well, it chops it up into two triangles. I'm going to call this A, I'm going to find the area of that. And I also have this other triangle over here, BCD, which I'm going to label K. K is just another way of writing area in some textbooks, so I'm just going to use K for that. Well, notice that the triangle that I marked A has a side angle side, so I can use the side angle side formula for that and find the area of that triangle. But over here, I don't have any angles in here, and there could be some way of doing it, but the most straightforward way is to figure out this diagonal length and then half side, side, side. But in order to find that diagonal length, I need to do law of cosines for side angle side. So x squared is going to equal to 31 squared plus 37 squared minus 2 times each of them being multiplied, and then cosine of the angle that's between them. So, you know me, I'm going to do some little work, some arithmetic first. So I'm going to do that. Get 2330, and then 2 times 31 times 37. And then put that into the calculator. Whoop, forgot a 3. And then I'm going to square root that. So we end up finding out that x equals 30.293. Now, what I'm going to do is I'm going to teach you something cool that the calculator can do that I don't know if we have done yet in this class. Maybe you have seen it in other classes. What I'm going to do is I'm going to tell the calculator that anytime it sees the letter x, it's going to plug in this number. And that button is the store button. So down here above the on button is the store button. So since the number I want to store is x, is the previous thing, I just pushed answer, and I'm going to store, and I'm going to choose the letter x. And the quickest way to get to x is that you can use any other letter that you want to. You just press alpha and that letter, and now anytime the calculator sees the letter x, it will output what we stored it as. Pretty cool, huh? All right, so now that I have that diagonal length, I have all 3 of these side lengths. So I'm going to find the area of this triangle here by using Heron's. Well, Heron's is, you have to find S. S is half of the perimeter. So one of the side lengths is X, the other side length is 44, and then the other side length is 56 for that triangle that we're going to do to find K. So again, if I put that into the calculator, X plus 44 plus 56, press enter first, then divide by 2, you end up getting this. Do you think this number is going to be important? Yeah, we're going to use this to put it into Heron. So I'm going to store this as the letter S. So now anytime the calculator sees the letter S, it puts that. So to figure out this area K, I'm going to do Heron's formula with this S value and the difference between S and each of those side lengths, which one of those side lengths is X. So I'm going to literally type that all into the calculator at the same time. So square root of S times S minus 44, and then S minus 56, and then literally S minus X. So we're going to put that on the calculator and end up figuring out that K, that area, that triangle is 662.700. Sweet, so I found half the area. How do I find the other half? Well, the other half is simply just a side angle side problem. So it's 1/2, did you forget at that time, the side lengths times sine of the angle that's between them. And some of you are probably wondering, it's like, why didn't I do that one first? It was so much easier. True. So the area A that I labeled is half of those being multiplied times sine of the angle that's between them. So I end up finding out this. But each of those on their own is the area of those triangles. I'm asking for the area of the quadrilateral, so all I need to do is add up those two areas, which is why now that one's there, plus the other area that I got is here. So that's why I waited to figure out what the sine angle side formula gave me, because that was a lot quicker to put into the calculator, and then all of the other work kind of would have gotten in the way. Now they're just right there. So all I had to do was add the two areas that I labeled as A and K. So that's area of triangles, and I believe that is unit 1 of the spring semester. So if you have any questions, make sure you ask.